Yesterday we talked about finding the slope of a line given 2 points. Today we're going to talk about finding the equation of a line. And now we've been doing finding the equation of a line given a graph, looking at it and determining it. We could also give you the description, give you some information, like what if I said the slope was 2/5 and the y-intercept was 6. I think you guys would tell me like, oh, well, slope represents m, y-intercept is b, y equals mx plus b, and you would say, y equals 2/5x plus 6. I think you guys would tell me that. I think you would just put that together. But that's when I give you the slope and I give you the y-intercept. What if you don't have m and b? What if you just have m and a point? Now, technically, yes, you could solve this one visually. You could tell me the equation of this. For example, you might say the slope is 1/2, so I'll go up 1/2, up 1/2, down 1, back 2, 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 until I get to my y-intercept and I see that my y-intercept is -1. At which point I can then say y equals 1/2 x minus 1. But there is another way. There is another way. Actually, there are multiple ways. The first thing I want to introduce you to is point-slope formula. We've been talking all about y equals mx plus b, which has a name. It's called slope-intercept form. And the reason for that is because we can clearly see the slope and we can clearly see the y-intercept when it's in slope-intercept form. But there's another form. The new form is point-slope form. And I want you to write this down. So pause the video and get this all down. Point-slope form is this. Y minus y1 is equal to m times the quantity x minus x1. Now, I'm going to prove this to you, and then we'll come back and we'll do the algebra. So this y minus y1 and this x minus x1 might look kind of familiar to you. Do you guys remember the formula for slope? The formula for slope is y2 minus y1 over x2 minus x1. That's our formula for slope. And do you remember from Algebra A, there's this rule that whatever you do on one side of an equation, you must do on another side. So we've got this number here and this number here, where those are, when they're separated by that fraction bar, they group them. And so what we're going to do is we're going to get rid of this fraction. We're going to fraction bust, and we're going to multiply both sides of our equation by x2 minus x1, x2 minus x1. Now, when I multiply both sides of the equation by the same thing, I keep my equation equal, but look at what happens. Those cancel out because any number over itself, remember, is 1. So those cancel out. And now on this side of the equation, I have y2 minus y1. And on this side of the equation, I have x2 minus x1 times m. I'm going to rewrite that because I just like my distributive property kind of looking one way. So I'm going to have x2 minus x1. Now, ooh, I got my y's over here, and since it's an equation, I'm just going to rewrite it. I like it with my y's on the other side. So I'm going to rewrite this y2 minus y1 equals m times x2 minus x1, where x1, y1 and x2, y2 both represent points. Well, do you notice that this looks strikingly similar to this? The only difference is that instead of x2, y2 representing a point, it represents any point on the line xy. So now, look at what we're going to do here with this information that we started with at the problem. We had we had the slope and we had a point. We had the slope and we had a point. So if I say that m is 1/2 and 8,3 is a point on the line representing x1 and y1, look at what happens. I'm going to take these and plug them in. So I'm going to have y minus y1, 3, is equal to m 1/2 times x minus x1. What was x1? 8. Okay, so now here comes the algebra part. Do you remember the distributive property? When I'm multiplying a quantity by a number, this number goes to both of them. So I'm going to say this is the same as y minus 3 is equal to half of x, right? 1/2 times x, 1/2 x, and half of 8. Half of 8 is 4. So minus 4. And then I want to solve my equation for y. We're going to get this into slope-intercept form. So I'm going to add 3 to both sides. And when I do that, I get y equals 1/2 x minus 1. Ha! I did algebraically here what I did visually here. And you can imagine why we would want to do something algebraically, because if this point was like 4729, that would be very, very far from the y-intercept, the y-axis, so we wouldn't want to have to count that whole way. We're going to do another video with some examples.